I want to lead you through some visuals and analogies to give context to Brownian motion and how fermions normally propagate in 3D versus a 2D electric system like John Searle's SEG, or even nanotechnology and metamaterials. Some quick background. Here are a couple recent articles about condensed matter physics to look into. High pressure states flip functions. Insulators become conductors. Bonds are forced together in geometric arrangements, even though they want to repel, which forms stable compounds that could not normally exist outside of that high pressure state, generating electric currents, superconductivity, magnetic fields, and more on a macro scale. Now, mimicking a high pressure state can generate exotic effects on a macro scale. In a high pressure state, things turn metallic and generate massive energy, because it took massive energy to initiate that high pressure state to begin with. Atoms and their constituents evenly separate under pressure, which is an aspect of coherence, an important concept in physics. A state of extreme cold mimics these effects, as well as extreme order, extreme voltage, extreme rotation, extreme speeds, extreme pulses, etc. This is a reason why nanotechnology is so effective. Extreme order and manufactured geometry simulate these effects. Restricting 3 dimensions and focusing 3 orthogonal axes worth of kinetic energy to 2 dimensions, planar, like a laser. There are 3 dimensions in space: x, y, and z axis, or cubic space. People are accustomed to understanding how energy flows in 3D random corkscrews. But a lot of that energy is lost through angular momentum and other factors. All of that randomized energy that would normally be bouncing and clashing in 3 dimensions can be compressed and forced to flow in 2 dimensions like a flat sheet, or in a ring like Saturn. Energy is absorbed or input in the x, y, and z axis, but only output from the x and y axis. There is an entire dimension and orthogonal axis of kinetic energy flowing in one face of cubic space. Even though the input and output might be proportional, that absorption and emission is asymmetric. All right, I want you to imagine that we are zooming into some metal, and zooming in all the way to those so-called electrons on the quantum scale. Now, the people walking around are the parts and constituents of the atoms. All of that energy is normally incoherent in Brownian motion, clashing around, all at random. All those people going their own way in different directions and different speeds, but that it's in 3 dimensions, on multiple floors. Just want you to get an idea of random and chaotic energy flowing, like static. Again, in 3 dimensions, on multiple floors, throughout an entire skyscraper. But now, instead of everyone just wandering around on their own like static, visualize the people marching together, all in the same direction towards an exit. All of those so-called electrons in motion. This would be like an electric current. Now you have people bumping around like a raging rapid, but at least in a common direction. Every person, every electron trying to make their way to the exit, and on every floor of the skyscraper. Normally, if a person walks in the building, then the person will eventually come out, so there is an even flow of in to out, pretty symmetric without any traffic jams. But now, instead of all the people entering and exiting through the front doors at the ground floor, imagine there is a bridge between 2 buildings, and only on one floor, right at the middle of the building. So now you have 3 dimensions worth of people on multiple floors trying to get to one bridge on one floor. That creates a lot of pressure and a lot of bottlenecking, translating that 3 dimensions worth of energy into 2 dimensions. The same amount of people are present, but now restricted to flow on one floor, on one plane. So now I want you to imagine a circular building with multiple floors. And not just one ring of buildings, 3 concentric rings. And there are bridges connecting each of the buildings, right at the middle floors, at the equator of the buildings, like spokes. All those people in a particular direction, all heading towards those bridges to cross between those 3-dimensional buildings in 2 dimensions on 1 floor. Now we're going to add another layer of complexity. Not just moving around the existing electrons that make up the building, but we're going to add more people and more energy to the system from the surrounding environment, adding more energy and load. More input equals more people joining the action. So imagine fleets of helicopters dropping people off on the roof. And in addition to people rushing the rooftops, there are also bursting through the front doors like Black Friday, bottlenecking that energy. All those multiple floors worth of people heading towards those bridges and spokes. People are going to be forced together even though they want their own space and want to repel. But more load means more pressure. So all the red arrows represent people coming in on multiple floors in 3 dimensions. And the blue arrows are people heading out in 2 dimensions. So the red arrows are fermions and the blue arrows are bosons. The bosons don't last for very long, and they split as soon as they exit the system, imparting kinetic energy like a focused beam, while also emitting light as a byproduct. Operating above superconducting levels means that there is an even proportion of people coming into the building and leaving the building. But it will get to a point where people cannot get out as fast as people are rushing in, which creates an overload. But in a conventional system, electrons are leaving, which leads to a meltdown. But in this case, there's an influx of electrons that leads to a superconductive overload, the inverse. And John Searle has said for decades that the SEG operates in the negative. He said, when so-called electrons overload and compress, it does the opposite of positive matter. Loss of electrons in a system means there is more room for the positive particles to bounce around and create heat, more positive charge. But if there's more electrons coming in than going out, after a point, there will be a superconductive overload rather than a meltdown, which can be as equally uncontrollable with disastrous results. But have to take note that these concepts are mostly shunned because of the stigma associated with negative mass and negative states. But there are still some references and experiments to look into. So even if the concept of negative mass is slightly off, a system can still display characteristics as if it exists or if it's present. So it's all in the interpretation of the same information. Also have to make it a point to say that this is not dealing with the flow of heat, like the Carnot cycle, but rather the internal kinetic energy of electrons. There's a difference between heat and temperature. Heat is Brownian motion in 3 dimensions on the quantum scale. But heat cannot exist in a Bose-Einstein condensate, because that energy is compressed and prevented from wildly bouncing around. That same energy is focused and ordered, coherent. So with more load, there is more pressure and more order, and the energy has to come from somewhere. So, abiding by the first law of thermodynamics, something must lower if a current is being generated, and what lowers in this case is the temperature surrounding the system, since the energy is being absorbed from the surrounding environment. But you can only absorb so much before the temperature drops to below superconducting levels, and the system develops an excess of negative energy, changing the state of the system itself. There's a lot more technical details, and I'm just trying to give a layman's version for people to visualize how the energy propagates. There's lots more to come, and if we had funding, I could provide much more professional videos with graphics that do these concepts justice.